Hello, what is going on, everybody? All right. Obviously, I'm not here today. This is our first ever flipped video. I'm stoked. I hope you're stoked too. I'm excited. I like making these. I have a good time with these. Okay. But obviously, today I'm not checking your homework. I can't take homework questions. All right. But we could talk about our weekends on Monday. All right. Today's lesson is always all about triangles and circles. All right. We're talking about circles today. Okay. Don't forget our test is Friday the 10th. That's a week from this Friday. We got a big day tomorrow, big day at parent teacher conferences. All right. I'm going to meet a lot of people. I'm very excited about that. Our song of the day is Bye 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 by NSYNC. Yes. Okay. So let's do some math. All right. Let's check it out. Check it out. Check it out. Check it out. Okay. Here we go. This is symbol right here. All right. You're gonna see this a lot in your in proofs and stuff. This symbol means circle. That means circle. Okay. This means circles, obviously because of the S, of this S here. Okay. Um, in a circle, every point on that circle is the same distance from the center. The center is not part of the circle because it is not on that circle. Okay, here's our center, all right, all of these points would be equidistant from the center. You have to excuse me if they're not all on the actual circle itself. I'm using my finger here, all right, but well, bear with me, okay? These special segments, all right, if I were to draw a segment from my center to a point on the circle, these segments are called radii. All right, these are radii. Okay, these are all radii. A single one is called a radius. That's a radius. A radius we always denote as r. So let's pretend that we wanted to find the area of a circle. Now you may have seen the formula for the area of a circle in your previous math classes, but that is pi times r squared. Your radius is r. That's why I wrote it here, r. Okay, that's to find the area of a circle. And I can't wait for when we talk about circles, when we talk about the circle's area and the sectors, and we talk about it'll be pizza day. You'll understand when I get there. Pizza day. It's a little sneak peek to pizza day. I am so excited for pizza day. We're not actually gonna have pizza in class, but you know, whatever. All right. So then to find the circumference, which is the perimeter of the circle, okay, that's 2 pi times your radius. All right. If I have two radii, I have two radii here, so this is one. Oh boy, and that's two. Okay, that's okay. Let's try that again. Here's one. All right, let's make that purple. Here we go. One more time for the. Here we go. One, two. All right, two radii. That's called your diameter. Okay, so another way to find your circumference is to do the diameter. D equals diameter. Diameter. Diameter, diameter, okay? D is your diameter. And as I said before, all radii of a circle are congruent. The diameter starts at one point in the circle and goes through the center. It's another point on the opposite side of the circle. All right, so why do we care about circles? Great question. I'm so happy someone asked that. All right, let's try to do a circle proof. Okay, a circle proof. This is going to be 8 steps, so it's going to take me a while. You're going to have to bear with me. Ooh, maybe I could use, maybe I'll just type it up. Type it up. No, that's not fun. All right, here we go. So first step, I'm going to write circle O. This tells me that O is the center of the circle. That's what that means. O is the center. Okay. 2, I'm going to say RO is perpendicular to MP, and those are 1 and 2 are both given who? Okay. If RO is perpendicular to MP, okay, well, what does that tell me? That tells me, remember, what do perpendicular lines make? Okay, what do perpendicular lines make? Perpendicular lines make right angles. So that tells me that angles, let's imagine that angle 2 is right at that, right there. Okay, angle 2 is right here. Okay, that tells me that angles 1 and 2 are right. Angle 1 and angle 2, right angles. Okay, and we say if perpendicular lines, then right angles. I'm not sure what that is. Okay. Well, now that since I know that they are right, I can also state that angle 1 is congruent to angle 2 if right angles, then congruent. Okay. Next thing. All right, I'm giving angle 1 is congruent to angle 2. All right, that's good. I know what you want to say. If we're looking at our two triangles here, all right, let's mark our picture. I know that these two are right angles. I know what you want to say, right? You want to say that RO is reflexive. So let's do that. Let's do that. RO is congruent to RO. Reflexive. Okay, good. All right, now we want to use this fact that O is the center of our circle. Okay, if O is the center of our circle, that tells me that every single radius in this picture is congruent. All of the radii are congruent. All right. So a radius, remember, starts at the center and goes to a point on the circle. So it starts at the center and goes to a point on the circle. All right. So OM and OP are both radii. And technically so is OR, but since we already use the reflexive property with that, we don't have to include it. So I'm going to say, since OM and OR, or excuse me, OM and OP are radii, that they are congruent. So I'm going to say that OM is congruent to OP. And our reasoning for this is going to be all radii of a circle congruent. Okay, I want you to put of a circle so that I know that you know a radius is inside of a circle. Okay, that's a segment on a circle. Okay, or that's a part of the circle. All right. That's why I want you to say of a circle. All right. So I have, what do I have so far? I have two sides and an angle. So I'm not going to write that. All right, but here we go. Make sure you're labeling the side as you go along. So now I can say that triangle what is it? OMR is congruent to triangle OPR, and that's by side, angle, side. Okay. And then I want to prove that MR is congruent to PR. So I would say MR congruent to PR. And that's because if congruent triangles, then corresponding parts congruent. Boom. Done with the first one. Okay. If at any point you were confused, feel free to go back and watch that. Sometimes I talk pretty quickly because I'm just so excited about it. I just heart math so much. But if you were confused, feel free to rewatch that. Okay. Feel free to watch that a little bit. So let's flip to the next one. Let's flip to the next one. So I'm just so nice that I included, like, it's written for you, isn't it? It's written up there for you. So I'm just going to make this appear for myself if it would. So I fancied myself a little bit, and I think I might have done that a little too much. Let's see. Is it going to appear? There we go. Check it out. Check that out. Holy buckets. I'm just touching it, and it's appearing as if from nowhere. Wow. Isn't that neat? Check that out. Mr. McConaughey, you're so funny. You're so cool. That's cool. Okay, so let's talk. I'm sitting here alone in my apartment laughing at myself. That's fun. Okay, so here we go. Auxiliary lines, right? Auxiliary lines. Auxiliary lines can be formed. It's a segment or array that can be formed by joining 2 points. So if I have this triangle here, right? Well, I want to prove that triangle ACF is congruent to triangle ADF. Right? But I don't have 2 triangles. I only have 1 triangle, right? So what I'm going to do is I'm going to state, okay, I'm going to draw in line AF. Okay, so I'm going to draw in line AF. And what you want to do to state that, you don't have to say if 2 points, then determine a line. All I want you to say is 2 points, determine a line. So cross out those if and the then. You can say 2 points, determine a line. All right. So I already said that this was congruent to this, and this is now congruent to that itself. You're also given that FC is congruent to FD. All right, so these two triangles are congruent by side, side, side. We don't use this, so don't worry about that 1, 3, 5 either. Okay. The biggest thing about this proof, the biggest idea to take away from it are these auxiliary lines. And we use those auxiliary lines to draw in triangles for ourselves, to create two triangles when we don't have two triangles, okay, or two angles. Sneak peek, maybe. I don't know. Let's talk to the guy. Here we go. Number 3. All right, here's our last and final proof for the day. All right, try to, hold back your tears, okay? This is your last proof with me for the week. Okay, so you're given circle O, so I'm going to write that circle O. That's given. You're given that AB is congruent to BC. Given. All right. If I'm given circle O, all right, well, first of all, let me ask you a question. Do I have two triangles here? No. I have a what? I have a four-sided shape. I have a quadrilateral, which we'll talk more about in chapter 5, okay? But I have a four-sided shape, so I want to form two triangles. So I'm going to draw in BO. Okay, so step 3 is draw BO. And that's 2 points, determine, sorry, a line. All right. So 2 points, determine a line. Then I could say, so I have this and this. So I could also use, well, let's use the reflexive property. BO is congruent to BO, everyone's favorite property, the reflexive. Okay. Reflexive property. All right, now I want to use this idea of circle O. So if O is the center, then that tells me all radii are congruent. Well, I have technically 3 radii here, 1, 2, 3, but I used BO already. So I'm going to say that AO is congruent to CO. AO congruent to CO, and that is all radii of a circle congruent. Okay. All right. So already I have a circle congruent. So now I have two triangles. I have a side, and a side. So I can prove that these two triangles are congruent. Triangle ABO is congruent to triangle CBO, and that is because of side. Okay. My goal here is to prove that BO bisects angle ABC. Okay, angle ABC is up here. So if BO were to bisect that angle, okay, that would mean that angles 1 and 2 are congruent. So to prove that it bisects, remember this, we talked about this last week a little bit, I need angle 1 congruent to angle 2. Well, angles 1 and 2, are they corresponding parts of our two triangles? Yes, they are. So I'm going to say that angle 1 is congruent to angle 2. Holy cow, I'm going to run out of time. Then I'm going to state the proof statement, BO, holy buckets, it's ticking, bisects. All right. To find the last 2 reasons, check my in-class notes on my Schoology page. That's all I have for you today. I hope you enjoyed my first lesson. If you have any questions, feel free to shoot me an email. I may have access to my email today. I'm not entirely sure. Bye-bye.